Is the microphone fine? Okay, we'll wait for like another minute and then we'll get started. Is the lighting fine for the Arduino right now? Okay, so then let's get started. Okay, welcome back. Welcome to Arduino Made Simple class number 2. I'm very happy to be here with you guys. And in this, let's get started. So if this is your first time coming to this session, my name is Vishwa Rao, and please watch the previous video and I've made the live stream a video. Please watch it at your leisure. So a quick recap from yesterday or last week. We learned what microcontrollers are. We learned the components that are inside of the Arduino board. We downloaded the IDE, which we use to program the Arduino. We learned what an LED is. We learned some basic coding principles with the Arduino IDE. And we created our first project, which is making an LED blink. And we talked briefly about breadboards. In today's session, we will redo our LED circuit to use a breadboard, and we'll also use a couple of jumper wires. We'll test to see if our original code will work with this new circuit. We'll add a button to our circuit and try to incorporate that into our LED. We will learn about for loops and if conditions, and we will modify our code to use the button. We will create our second project, which is a traffic light simulator, and we will briefly talk about ultrasonic sensors if we have time. So let's rebuild our circuit. So this picture is from Fritzing, which is an application that you can use to build circuits online or just build circuit diagrams. They won't actually work, and it's really useful for just showing people what your circuit is. And if you want to go check it out, you can download it. The volume is low. Let me change something. Is it better now? Okay. So I was talking about fritzing and how you can use it to build, or you can use it to build circuit diagrams and to see how your circuit will look. Increase it more. Okay. Is that good? So in this circuit, you'll notice that we have instead of having our LED directly plugged into the ground port and the pin 13, we have a cable connecting the ground pin to this rail right here, and you'll see that this whole rail is kind of highlighted in green. That's because when we plug this ground cable into this rail, the ground or the ground will extend through the whole rail. So if we plug another wire here, we'll get this same ground. And that's what we did with the LED. We plugged the ground cable from the LED's ground leg into the ground rail. And then we simply plugged pin 13 to the LED's positive leg. So let's start building our circuit. So the first thing we need to do is add our LED onto the board. So we just simply add it in the middle of the board, and you want to make sure it's uh, it's horizontal or parallel to this break parallel to this break that's on your breadboard. The reason is because if I switch back, um, you'll notice that when I plug the LED here, you'll notice that this whole row lights up green or is highlighted in green, and same thing with this row. So that's because these columns are connected to each other, and these rails are connected to each other. So they're not all going across they're not always in rows. Only the rails are in rows, and these main ports are in columns. So, so you want to remember which rail or which column you plugged your positive pin into and your negative pin. And the next step is to plug our jumper cable into ground. Now, for ground, there are some colors you can use for color coding your cable so it's much easier to read if someone else is looking at your circuit. So for ground, you can use the general color you should use is black, but you can also use white and green if you don't have black. So I'm going to use white, and we're going to plug it into our negative rail. So the next thing we need to do is actually connect the LED's ground leg onto the ground rail or into the ground rail. So we need to take our another wire, and I remember I plugged the ground pin on the right side of my LED. So I'll plug my ground on the same column that I plugged my ground on the LED, and I'll plug it into the ground rail. So it should look just something like this. You'll notice that one leg is on the same column as this ground wire, and the ground wire is connected to the ground rail. So the last thing we need to do is plug in our positive cable, and for positive, the general color general color is red, but you can use pretty much any color as long as it's not white or black. So I'm gonna use red, and we plug it into the other column that our LED's leg is in. So we have our uh, positive positive wire plugged into the positive leg of our LED, and we have the ground wire plugged on the same column as our ground leg on our LED. So now if we run our same LED code, which I'll uh, open up real quickly. If we run our LED code, um, we should see that the LED will light up. and you'll see my LED is now blinking. So now that we've built our LED onto the breadboard and we know our code can work, or our original code works, we can now start adding a button. So using the same LED circuit, we can just add a button right next to it, and it'll work the same way. But when we press the button, it'll light up. So we have to change that in the code. So you'll notice that this button has 4 legs. So uh, one leg here, one leg here, one leg here, one leg here. And you'll notice that it's right in the middle of this break. Now, to understand why it's in the middle, we have to understand why or how an LED or button works. So when we press a button, the button will complete a circuit. So the two of the legs will have the power going through it, but the power will never go through the button until the button is pressed. So once the button is pressed, the power will then pass through the button. So that's how a button works. And you'll notice we have this new component here. Now that's a resistor. And a resistor can be used to resist current. And in this thing, it's basically going to hold the power back and then release it once the button is pressed. And then we have our 5-volt plugged into the other side of our button. Now the button doesn't have a polarity, meaning that if you plug positive and negative on the opposite sides, it'll still work. It doesn't matter which side you plug it in. And then finally we have our pin 10 plugged into the other opposite side of the button, so that once the button is pressed, the signal will reach pin 10 and it'll complete the circuit going to the Arduino. So let's start building this circuit. So let me turn off the LED. So the first thing we do is we'll plug our button onto or in the middle of the breadboard and make sure the pins aren't like this, right? So you'll see there are 4 pins. You'll see there are 4 pins on this button. Make sure that the pins that are closest to each other should be on the same side of the breadboard, not the pins that are farthest from each other. So once you've plugged your button in, it should look a little bit like this. So the next step is to connect our button to ground. Now you'll recall that we already have our ground rail that has ground in it, so we can use that same rail for the button. And since we're just plugging a resistor in for the ground, we don't really need a wire. We can just plug our resistor in directly. So we'll plug our resistor to the ground rail, and we'll plug the other end of the resistor to one side of the button. So I'm plugging it to the left side. So the next step is we need to give 5 volts or provide 5 volts to the button. So we'll simply plug one end of our cable to 5 volts and the other end to the positive end of the button, or the end you didn't use for negative. So the final step is to plug our button to pin 10. So we'll plug one cable to pin 10, and we'll plug the other end to the ground side. So it should be on the opposite side of the breadboard, but it should be on the same side of the button, if that's not too confusing. So it should look something like this. So has everyone gotten this far? Okay. So for this circuit, um, the button needs both positive and negative, and for our negative, we've plugged a resistor. We've plugged a resistor into our ground rail, as you can see here, and we've plugged our 5 volts into the opposite side. your button. It may not look like the one I have. It may be a little bigger, and it may be like yellow, a yellow button. Just try looking for something with four legs on it. And then finally we have our um, signal or pin number 10 plugged connected to our button. So when the button is pressed, the power will flow through and it will reach this pin 10, which will then tell the Arduino that the button is pressed. So did you find the button in your starter kit? Okay. So now that we have our button inside of our circuit, or inside of our circuit, we can now start programming it. But to program our button, we need a special statement called an if statement, or yeah. So if statements are conditional commands in a programming language, and they basically take a condition and evaluate it. If it's true, it follows a certain path, and if it's false, it follows another path. And in our project, our if statement will be if the button is pressed. That will be the evaluation. So let's start coding. So I'll use my same LED code, but I will take out the part that makes it blink and just keep the um, LED high, the digital write LED high part. So in order to start our if statement, we have to simply type, or actually let's start telling the Arduino that there's a button. So for our button, similarly like an LED, we have to create a variable first. So if you recall, we used the data type integer for our LED variable, and for the variable name, I'm going to call mine button. And what number do you guys think we'll put inside of, or we'll set the variable button to? So if you guys guessed pin 10, then you're correct. Or if you guys guess the number 10, you're correct, because we want to set it to pin 10. So once we've done that, we have to tell the Arduino that pin 10 is an input, because the button is going to be sending the signal to the Arduino. The Arduino is not going to be powering the button. So we'll just say pin mode, and we'll use button. So the Arduino goes back and sees that it's pin 10. And we'll set it, instead of output, we'll say input in all capitals, or in all capital letters. So now we've told the Arduino that our button, or our button that's connected to pin 10, is an input. Now we have to find out if the button is pressed, then we want to turn the LED on. So the way we start an if statement is by simply typing if, and then we add two parentheses and then curly brackets at the end. So this curly bracket is where our code will go if the evaluation is true. So for the evaluation, we need to find out if the button is pressed, and similarly like we said high here, we can ask the Arduino if the button is high. And instead of saying digital write, what we can say is digital read. So we find out what that pin is, the value of that pin is. Is it 1 or 0, or is it high or low? So inside of this digital read parentheses, we'll put the uh, variable name button, and then we'll use two equal signs, and we'll say high. The reason we use two equal signs instead of one is simply because in Arduino, if you're trying to compare something, you use two equal signs, and if you're trying to set a variable to a value, you use one equal sign. So we have our evaluation inside. Now we can put our code inside. So all we have to do is copy this code inside of our if statement. And now when we download the code, let me plug my Arduino in. Okay. So now when we download the code, we should see that the Arduino will, the LED won't turn on immediately, but it'll turn on once I press the button. And you'll see that not once I press the button, the LED turned on, but when I release it, the LED doesn't turn off. So why do you think that's happening? I want you to look at your code for a second and try to find out why you think it's happening. So if you guessed it's happening because we have no statement to ask the Arduino if the button is low, so we're never going to turn the LED off, then you're correct. Now, to ask the Arduino if the LED is low, we can create another if statement, but we know that if the LED is not on, it has to be off. Or if the button is not on, or button is not pressed, it has to be released. So we can just use something called an else statement. Now, an else statement can only be used after an if statement is used. You can't just simply have an else statement because it'll never run. So once we have the else statement, all we have to do is digital write and turn the LED off. So has everybody gotten this far so far? Okay. So now that we've turned the LED off, if we run our program, we should see that a button, when we press it, it turns on, and when we release it, it turns back off. So now we've successfully added our button and used it in our code. So the next thing we're going to learn about is for loops, or are for loops. So what are for loops? For loops in a programming language help in running a set of instructions repeatedly. They can be used for an defined number of times, or they can run for an indeterminate number of times if you use a variable inside of the for loop. And it runs until the condition you provide is false. So in our project, we'll make the LED blink 5 times once the button is pressed. So let's get started. So obviously, we can make the button literally hard write the code to make the button blink 5 times, but since that's hard to do, all we have to do is inside of our if statement, I've deleted the code, we have to start writing our for loop. So to start our for loop, we just simply write for again, and we put parentheses, and then we put curly brackets again. So it's similar to the if statement. And inside of this parentheses is where our evaluation will go in. So for the evaluation of a for loop, there are 3 steps. There's the starting value, the ending value, and the incremental part. So for the starting value, all we have to do is create a variable, and for our cases, we'll just set it equal to 1. So you'll you'll probably be wondering why we're setting this variable inside of the void loop. Well, it's because this code it won't overwrite the value x. It'll just reset it to 1 every time we run this code, and only the code inside of this for loop and the for loop itself can access this variable. Nothing else can access the variable. So once we've added once we've set the starting value, we put a semicolon and we'll set the ending value. So we want to run this until x is less than 6, or as long as x is less than 6. Once it's equal to 6, meaning it's run 5 times, we want to stop the for loop. And then finally, we'll type x plus plus. Now what x plus plus does is it sets x equal to x plus 1. So it basically adds 1 to x. So now we've finished writing out our for loop. We can start with the code that goes inside of it. So the first thing we need to do is turn our button on, or turn our LED on. Then we delay I'll delay for 1 second. Then we turn it off again, or, and then we wait 1 second again, so it doesn't turn back on immediately. So now if I run this code on my Arduino, you'll see that when I press the button, the LED will blink 5 times. And you'll see it stops exactly once it's blinked 5 times. And when I press it again, it'll blink 5 times again. So has everybody gotten this far? Okay. So now let's get started with our traffic light simulation. So for our next project, we'll simulate a traffic light. And the reason I chose this project is because traffic lights are actually also used or run by microcontrollers. So that's why I decided to I decided to create a traffic light project. So for this project, we will utilize a button to start the program, and we'll add two more LEDs. In my case, I'll add a green and yellow one. And when I press the button, it'll repeat the sequence green, yellow, and red 3 times. So the steps to complete this: first, we will add our LEDs to the circuit. Then we will create a new sketch in the IDE. We will then code the traffic light pattern in the IDE, and then we will incorporate the if statements and for loops. So our program starts when the button is pressed, and it repeats it 3 times before it stops. So this is the circuit. And similarly, like we did with the first LED, you'll notice we have one ground rail, which all the LEDs are connected to. And then all of our positive for the LEDs are connected to the pins directly. So let's get started with the circuit. So the first step we need to do is to add our other LEDs, and I recommend keeping the positive end of the LEDs on the same side. So in my case, all of the positives will be on the left side of the LED. And once we have our LEDs plugged in, we can then add our ground. So instead of having to add another rail, we can just use this existing ground rail and plug our LEDs into here. So one end goes into the ground rail, the other end goes into the ground side of the LED. And then we do that for the green LED as well. So now we have all of the ground cables connected to our LEDs. Now we can start adding the positives. So for the yellow LED, I'm connecting it to pin 12. So, and then for the green LED, I'm connecting it to pin 11. Let me make sure the circuit, okay, good. So let's go over the circuit again. We have our ground rail connected to the ground of our Arduino. We have the LED's ground pins connected to the ground rail directly, and we also have our positive of the LEDs connected to the pins. So has everyone gotten or finished their circuit? Okay. So let's open up a new sketch on Arduino IDE, and and then let's first start by initializing our variables. So we have four variables: the red LED, the yellow, the green, and the button. So we have red, and if you remember, red was set to pin 13. Then we have yellow, set to pin 12. Then we have green, set to pin 11. And finally, we have the button, which is set to pin 10. So, uh, so now that we've initialized our variables, we can now tell the Arduino whether they're an input or an output. So we'll do pin mode, and the red LED is an output, and same thing for the other LEDs, so yellow output and green output. And then finally, we have our button, which is an input. So that all of our, we've told the Arduino what the variables are. We've told the Arduino that what, we've told the Arduino what pins are inputs and outputs. Now we can get started with our main code. So the first thing we want to do is we want to make sure that our main code only runs when the button is pressed. So we'll start with our if statement. And does anybody remember what the command we put inside the if statement to find out if the button is pressed? Okay, so that's kind of close. You said digital write, but it's actually digital read. And yeah, equals equals. So we type if digital read. The reason we use digital read instead is because we're trying to find out if the button is pressed, so it's like the Arduino is reading from the pin instead of writing it, which is like turning it on. So we type digital read, and we'll use the variable button, and we'll see if it's equal to on, or if it's on or high. So now we have our area to put our main code once the button is pressed. So now we need to make the for loop so that the LEDs run the sequence only 3 times instead of repeatedly. So we'll type for, and does anybody remember what we have to put to make it 3 times, run 3 times? Yeah. So for mine, I'm just gonna make it int x is equal to 1. So it's more convenient to count from 1 than from 0. Then we'll do x is less than 4 instead of 3, and x plus plus. But yours was right too. Okay, so now we have our for loop. Now we can just make our LEDs run in a sequence. So the first thing we need to do is turn our green LED on. LED or green. Then we'll delay, I'll put it as 3 seconds because the green and red will always be left on for longer than the yellow LED. So I'll turn on the yellow LED now. And then we'll delay, I'll put delay 1 second. So it's a shorter amount of time. And then we'll have the red LED, which I'll keep it on for 3 seconds as well. So now if we run this code, we should see that once we press the button, the sequence will repeat 3 times. Oh, I forgot to add a semicolon in my code. Okay, it's downloaded. So when I press the button, okay, looks like the green LED is short-circuited. Let me just check, just get another LED real quickly. Okay, so now I have my 3 LEDs, but you'll notice that they're all on and they didn't turn off. Now if we look back at our code, you should find the, it should, you might be able to find the reason right now. But if you haven't already, it's because we haven't turned our LEDs off at all. So we're just turning the green one on, then the yellow one on, then the red one on. We haven't done anything else. So the way we do this is when we turn the yellow on, we have to turn the green off, or else the green will remain on. And we'll turn it on. And when the red is on, we have to turn the yellow off. And finally, at the end of our code, we have to turn red off. Now, you may be asking why didn't we just turn it off up here? Well, the reason we didn't do it is because if we put it up here, the red LED will not turn off once the for loop is repeated. So you have to turn it off after this 3 seconds. So has everyone gotten this far? Okay. So now let's download the code and test to see if it works. So the code's downloaded. When I press it, first LED lights up, then the second, and then the third. And you'll see that the LEDs don't remain on. So let's see if it stops after 3 cycles. And you'll see the cycle stops after 3, after it's repeated 3 times, and when I press it again, it'll start again. So that's it for this code, and that's it for this class. And I'll talk a little bit about ultrasonic sensors because that's what we're going to use in the next class. So let me switch. So that's how an ultrasonic sensor will look like. It kind of looks like two eyes. And the use of an ultrasonic sensor is to measure the distance between the ultrasonic sensor and something else. So many cars use it when when the car's backing up, it senses the distance between the car and any objects behind it. And the way it works is it sends out uh, a sound, the frequency is above 20 kilohertz, which means that humans cannot hear it. And it detects the speed in which the sound comes back. So the sound goes out and then bounces off the object and comes back to the ultrasonic sensor. So it has a trigger pin and an echo pin. So the echo pin will receive the echo and the trigger pin will send the echo. And the way it calculates it is it knows the speed of sound is 343 meters per second, and the time is the elapsed time between the trigger and the echo, and the distance is the speed times time divided by 2. Now, the reason it's divided by 2 is because the sound waves have to travel the distance 2 times, because it's going that way and then bouncing back. So that's how ultrasonic sensors work, and in the next class we'll use it to detect our distance, and we might even do a burglar alarm with it. So that's it for this class. I hope you guys enjoyed this class. Let me check if there are any questions. So do you guys have any questions? Review the last code? Sure. So the first step we did was we initialized our variables. So we have the red LED, the yellow LED, the green, and the button, and we set them to their pin numbers. The next step we did was we set the LEDs, or we set the pins to the specified output or input. So all the LED pins were outputs and the button was an input. Then we wrote an if statement to check if the button is pressed, and only then do we run our main code. Next, we created a for loop, and we had our starting variable, which was x, and we set it to 1. And we run this as long as x is less than 4, and every time we run it, we add 1 to x. And finally, we added our code that's basically sequences between or switches between the LEDs in a traffic light pattern. So that's it for this video. I hope you guys enjoy it, and I'll catch you guys next time.